Hey guys, welcome to the CS50 readability walkthrough tutorial and hints and clue. So we'll basically go through into the 8 sections here. So by the way, we are not having any answer in this video. So if you want any answer in this video, please go to another video link below. But try to solve this problem by yourself. So in this, initially we have 8 sections here. So the programs, reading grids, letter, words, sentences, calculations, output, and we'll go through the overall concepts. So the first, we have two examples here as in the, I think in the questions we have this kind, the same tutorial examples. So for example, if the user key in the text here, so our program will generate this grid tree. So a slightly complicated text will have more higher grades here. So basically the grades is affected by two kind of factors, longer words and more words per sentences. So if we combine into a formula we call a Coleman-Liau's index. So this one will include this index is equals to 0.058 with these two variables. So L is equals to average number of letters per 100 words and S is equals to number of sentences per 100 words. So L is basically linked to the letters, S is linked to the sentences. So we go through the example and see. So for see how can we do applications here. So once we have the letters, the words, and the sentences, we can find the L and S. So L is basically equals to the letter divided by words times 100 equals to these digits. So S is basically sentences divided by words times 100. We get this value. So once we have these two values, we plug into here. So we get this 3.0435. Then we need to round off to grade 3. 3, so we get the conclusion is grade 3. So the same examples, we find these three value. So we use the L to get letter divided by words. We get it times 100. S is equals to sentences divided by words times 100. We get this value. So we plug into the formula, we get 4.55 run off to 5. So we know it's grade 5. So our program will have to do these certain steps, certain steps, certain steps. Then we will know this grade. So that's why we divide into several sections here. So we go to the letters. So letters is, for example, off here we got 3 letters here. So it's like how many letters in a word. So if you count one by one, we get 65. So words is letters is actually each letters in the text here. So it's uppercase, lowercase, but it's not included with the punctuation, digit, and other symbols. So the method used here, we use some concepts here to keep track of the counting. We use this example as provided in the CS50. So we also will use this ctype.h. So these two are quite related. We can optionally use this or not use this. Depends how you want to apply it. So we go through this example, a score tree. So basically we try to understand what is this program does. So basically user need to key in the number of score. So for example 3, so the user need to key in 3 score. So we will get the average score. We calculate automatically to get the score here. So by logic, we know the average score is this 3 plus together, divide by this, we get this. So we know the formula here. Okay, so how do we write this? So before that, we need to understand that this is an array. So the length is here. So this is array. This 3 is plugged into this into array. So the sum, so for those people who wants to understand more about this symbol, it's basically a plus equals to b is actually equals to a plus b. So basically, this one later we'll go through. So we need to include these two into the library. So this is the function here. So the average, we have two. One is the length, which is the number of score. The array, which is this tree, this array. So this is length, this is array. So once we know, we need to have a number to keep track. We call local variable. This is very important. This is what we're going to use to find our these three letters, words, and sentences. So once we have the initial sum equals 0, so we use a loop I equals to 0, I less than length. So our length is 3, so it's 3 here, so I is plus plus. So sums plus equals to array I. So from here we try to understand what is happening here step by step. So for example, we are using this as example. So initially the sum is equals to 0. So by using this formula, once the user key in these three value, the sum was equals to 0.1 plus 1 equals to 1. 1 plus 2, 3. 3 plus 3, 6. So this is how we get the 6 here. So the sum lastly will add on all the values here. So 6 here. So with this formula, we use the float here to calculate a more precise digit here. That's why I use the float here. So 6 divided by 3 equals 2.0. So basically this is what the average function does. So we plug into here. So the main functions is initial get initial. So ask the value key in this the value here. So once we key in a length here, so we can use this as a length. So use this as a length. So I equals 0, I less than n, s plus plus. So this loop will ask the user to key in one by one. So this is what it does here. So once we get all the score here, we know this three, we know 1, 2, 3. So we can use this formula here. So you can see the average here. So the n is actually here. The scores will go through here. So we'll apply this formula, then we'll get the value of 2.0. So basically we'll use this concept as I call here as a sum concepts for our method to find the tree value. So next we'll use we'll expand slightly with the ctype.h. So there's a lot here. So I'll try to touch the most important here, which is alpha beticals, which is to determine whether a character is a letter or not. So we can use this to find our letters. So example of the code here, we must include the ctype.h. So get characters. So if we input the C here, if this C is a letter, so you print this. So this is letter, yes. So else, no. So you can reference here to apply to find our letter here. So once we are clear with letter, we go through the words. So the words, we need to understand what is words. So basically, word is to count the number of words is in a sentence. So words, for example, this is considered a words 1, a 2, a 3. So there's a 14 here. If you count properly, there's a 14. So there's a few things that we need to some assumptions in these questions. So words is any sequence separated by a space. So sentence will not have space. There's no multiply space in a row. This basically we just try to limit the other space possibility. So we go through the next slides to understand more. So same thing, we need to use a variable to keep tracks the sum. So the same concepts. So we understand the letter and space. So for example, we have this text here. So basically we can see here is 1 word, 2 words, 3, 4, 5, and 6. So there's a 6 here. But try to see how many space here. There's 1, 2, 3, 4, 5. There's 5 space here. So basically the link here is a +1. So to be more hints here, we can put the sum. Instead of 0, we put 1. So we start from 1. So basically the space will be equal to the words. Yeah, the hints is here. So after we find the words, we'll go through the sentences. So sentences is, let's see, what is sentences? Define with any periods, any exclamation point, and questions marks indicate a sentence. That's simple. So you can say 1, 2, 3, 4. So there's a 4 here. So we can another example. So the same example here. So we can see there's a 1, 2 sentences. 1, 2. So the symbols is directly linked with the sentences. So probably the sum is very direct, is equals to 0. So we can use the same concept to find these 3 values here. So once we find the 3 values here, we'll go through the calculations. We'll plug the value here to L and S. So the same concept, we use 65 divided by 14 times hundreds. So S is equals to sentence divided by 14 times hundreds. So we get these 2 values here. So plug into the formula here. So we get 3.0435. We need to round off to 3. So to round off, we need to use whether the max.h round or f. So we look into .f. So because from I think is the most simplest way. So we look back the same example here, which is in the CS50 source code. So here you can see it's slightly more decimal. So let's look directly here. So the floats here, a bracket floats is to get a more precise than integer. So probably the calculation need to add similar method here. And also if you want to get to round off value, we can put the .f. So for example here we can see .1 is a 1 decimal after is one number after 1 decimal after decimal point is 1.2, 2.0, 10.7. So we want to round off, we can put point f. Right? I think there's a clue here. So at last we move to the output. So once we've calculated all these value, we know it's a grade 3. What if the value is not 3? It's like 0.1. So you fall under this category. So basically there's a 3 category here. I put conditions. So for example 0.1 is less than 1. So it will go to here before grade 1. If for example if 16 or 16.1, so we move the output will print out the grade 16 plus. Else if between condition 1 and 2, for example 3, we need to print the grade index after round off, for example grade 3 like this. So here this round off here 3, so we need to go through to print out F grade 3. So basically this is our last steps. So overall we need to include a library here, so you can add more library if you want. So initial means we need to let the user to key in the value get string. You can use this library, this method here, these functions. So we can use the sum concept, decline, initial, local variable, to the same method to find these 3 value. Alright, so probably I think the word is not so direct, so need to plus 1. Let me check again. Yes, the words need to plus 1, so that's correct. To plus 1. So need to pass a certain condition to add count. Yeah, need to decline whether is it a letter or non a letter. So this is all some condition that we need to add on. So once we get these three value, we will plug into this index. So we need to use more precision data type like float instead of integer. So we need to round off to the nearest number. So the outputs will according to 3 different categories. So here, here, here. So basically this is the overall concept of this problem. So that's it. So thanks for watching and try to solve the problem by yourself. Happy coding!